Hi there. Today we're going to start something new for us, something you probably haven't seen before. We're going to do 9.3 sequences. All right, we have a problem here that we're going to refer back to kind of throughout this whole chapter. So let's go through this and make sure you understand it, and then we'll kind of refer back every once in a while. So it says your friend buys you a concert ticket for seat 995 in a concert hall with 65 seats in row 1, 67 seats in row 2, 69 seats in row 3. So if you can kind of envision that, really it's just getting wider the farther back you go. So in this row there's 65, and then it's a little bit wider, a little bit wider. And so each time it looks like that we are adding 2 more seats in there. The concert hall has 40 rows of seats. All right, so we have several questions here. First of all, how many seats are in the last row? So how big does this end up getting? The next question, how many seats are in the concert hall total? And the last one, describe the location of your seat. So how good of a friend do you have there? Where is your seat located in this big concert hall? All right, so we're going to kind of approach these, and in class we kind of go through and we make guesses on each one of them, but if you think about this, you've got this row that has 65 seats, and then you've got 67, and then you've got 69, and then you've got 71, and so forth, so forth. And we could figure out how many seats are in the last row, but we'd have to sit there and go through it quite a while, maybe in our calculator, and we're not looking to do that. We don't want to just sit there and press +2, +2, +2, +2. That's the opposite of what we're doing in this chapter. All right, and so in how many seats are in the concert hall, well, you'd have to look at how many are in each of the rows and add that up, which again would take forever. And then we're going to figure out where our seat is. So we're looking for ways around that, looking for patterns in this sequence. So before we go back and look at answering some of those questions today, let's talk about what types of sequences we have. All right, we can kind of classify them a few different ways. First of all, you can decide if they are finite or infinite, and that's pretty self-explanatory. Finite just means it ends, infinite continues forever. The other way to classify is by arithmetic or geometric. Arithmetic sequences are sequences where you're going to add the same value over and over and over. Geometric sequences are something where you are multiplying by the same value over and over and over. So if you think of the concert hall problem, if you would have listed out how many rows or how many seats were in each row, 65, 67, 69, 71, would that be arithmetic or geometric? Well, it'd be arithmetic because we're adding 2 to each row. All right, so let's just real quick go through this and classify each of these by finite or infinite, and then arithmetic or geometric. So this first one. As you go from one term to the next, you can see that you are adding 10, adding 10, adding 10, adding 10. Okay? Also notice that it stops at 50, it doesn't continue on. So this would be considered finite because it stops, and it is arithmetic. All right, see if you can do the next two. Go ahead. You're going to have to pause the video quite a bit in this because I'm going to have you write something, and then I'll quick show you what the answer is and make sure you got the right answer, and then keep moving. So be ready to pause quite a bit. All right, hopefully you caught that both of those were infinite geometric sequences. That second one's a little trickier with the fractions, but you're just multiplying everything times 1/2 over and over and over. One thing that is kind of special to infinite sequences, and it's going to pop up as we progress through this sequence stuff, but I thought I'd throw this in here now. When you're looking at an infinite sequence that goes on forever, there actually can oftentimes be a limit to that sequence. And we look at infinite sequences and try to look at them and decide, is that converging or is it diverging? If your sequence is converging, it means it approaches a limit, and that's getting closer and closer as you create your sequence. That value at that next term is always getting closer and closer to a particular finite number. Then it would converge. Now, if your sequence does not do that, then we say that it diverges. All right, so looking at this first, we're just going to look at a couple of these and decide if they are converging or diverging. On this first one, you have 1/1. Okay, 1 over 2, 1 over 3, 1 over 4. That's getting smaller and smaller and smaller, and will continue to get smaller and smaller, and it's going to be approaching, as it gets smaller and smaller, 0. So if it approaches a finite number, like 0, then I'm going to say that this one, that this one converges. All right, let's look at the next problem. You have a 2 over 1, so that's like 2. Then you have a 3/2, that's 1 1/2. The next one's 1 1/3, 1 1/4, 1 1/5, 1 1/6. That should be getting closer and closer and closer to 1. So if it converges towards a finite number, we'll note that. On the next one, we have 2, 4, 6, 8, 10. That just keeps adding 2, getting bigger, 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 bigger. That is not approaching a finite number. That's diverging. And then the last one goes -1, +1, -1, +1, it's just flip-flopping. It's not getting close to something, it's just bouncing back and forth. So if it's not approaching something, then we would say that it diverges. Keep this in mind as we move forward over the next few days. This idea of converging and diverging will come back to us. All right, so that was a specific situation. We kind of started with an example that meant something to you. And so now let's go back and just write a generic formula or a rule that we can follow. I put a little remember sticky note because you have to know these two rules. So recursively, to write a recursive rule. Now notice up here that it says arithmetic. So for an arithmetic sequence, to find the nth term, you're always going to take the previous term and do whatever your rule says. So since it's arithmetic, we know that we're going to add something. In the concert hall problem, we added 2, but that's specific to that problem. So each problem might add a different value. We call it whatever the common difference. So the common difference in the concert hall problem was 2. You kept adding 2, adding 2. So the common difference we call D. So whatever you find that the difference of the two numbers is, that's what you're going to add. All right, so this right here is our recursive rule for an arithmetic sequence. Let's look at an explicit rule. I kind of worked us into this one because if you think about this, on an explicit situation, you have your first term typically given to you. All right, to get to the second term, I'm going to take the first term and add D. That's what this recursive rule says. But what if I need the third term? Well, I would take the first term and I would have to add D times 2, right? I'd have to do it twice to get to the third term. And for the fourth one, I'd have to take the first term and I'd have to add D 3 times. So let's come up with a rule then. To find any particular term, it looks like we have to take the first term and we have to add D how many times? Well, it depends on your n, right? So look at this. This was 4, we had to take it times 3. 3, we had to take it times 2. 2, we had to basically take it times 1. So it's always 1 less. That's where we got that 39 last time. So we're going to take it times n minus 1. All right, that's an explicit rule that we'll use a bunch. Now remember, again, these are for arithmetic sequences. Let's look at defining some rules for a geometric sequence. Not a whole lot different. A sub n is going to equal, again, recursive means you have to look at the previous term. But since this one is geometric, we're going to be multiplying. So instead of adding, I'm going to multiply. And it's not D because when you're multiplying things over and over and over, they don't have a common difference. What they'll have is a common ratio. And so we take it times R for ratio. So explicitly, if you're given a sub 1, okay, to find a sub 2, you're going to take your first term and you're going to multiply it by R. But if you need the third term, you're going to have to take the first term and multiply it by R. But if you have to multiply it by R twice, that's not 2R, that's going to be R squared. So the fourth term, I would take A1 and I would take it times R to the third power. So now let's summarize that in a nice rule for any term. So for the nth term, I would always take the first term, I would multiply it by R, and what would that power need to be, do you suppose? It's 1 less than the term, so to the n minus 1 power is how many times you'd have to multiply by R. Okay, 2 important formulas, know those. Now that we know how to write those rules recursively and explicitly, let's look at a specific example that we were dealing with earlier, the concert hall. All right, to write a recursive rule for the concert hall, remember that you've got to know the term before it. You got to know how many seats are in the row before it, the row before it, the row before it. All right, so looking at this one, a sub 1 would equal however many are in the row before it, which I don't know, so I'm going to write a sub n minus 1. And then I have to know what the pattern is, and I'm just adding 2 seats every time. That's the recursive rule for the concert hall. Let's try writing an explicit rule for the concert hall. This one you have to know the first term. Well, I do know the first term. There were 65 seats in the first term, so I'm going to write 65 seats in the first row. And then you have to know the pattern, and we already said, yeah, I'm just adding 2. But remember, according to the rule, then I'm going to always add 2 n minus 1 times. This is going to allow me to find how many seats are in any particular row, which means I could go back to the concert hall slide at the very beginning of my notes and use this to figure out how many seats were in the last row. Remember that question, how many seats were in the last row? So I would just have to, if I want the 40th row, then I would have 65 plus 2 times 39. And that is 143. 143 seats in the back row. All right, so let's practice writing those formulas for some specific situations, kind of like we did with the concert hall problem earlier. All right, so this first one we'll do together, then you can pause and do the other 2 on your own. So this first one, this was, again, remember, this one was an arithmetic. These are the same ones we did earlier. This one was arithmetic, so a recursive rule. A sub n would have to equal the previous term. Since it's arithmetic, I'm going to add, and then looking at this problem, it looks like I'm adding 10. So that's the recursive rule for this sequence. The explicit rule for this sequence, the explicit rule, you always have to start with your first term. Well, in this sequence, my first term is 10. And then it's arithmetic, so I'm going to add the common difference. When you look at it, it looks like I'm adding 10 every time. And how many times would I add it? Well, n minus 1 times. And there's your explicit rule for this sequence. Okay, so go ahead and pause the video, and you finish out the other 4 boxes there, and then we'll move on to the next thing. Okay, take a minute to check your answers with mine, fix anything that you have wrong. Go ahead and pause the video to do that, and then we'll move on. All right, today's homework assignment really isn't very long because we really want to focus on understanding sequence notation and understanding what's going on. One of the big things is understanding in a sequence how we label things. And so if you have an a sub n, we've already talked about how that just designates a certain term. And if you think about it, I'm just going to totally make something up here. Let's say it's a 9, a sub 9. Okay, that's the 9th term. So what would be the term after it? Well, it would be the 10th term. And after that would be the 11th term. And after that would be the 12th term. What would be before that? Well, it would be the 8th term, and then the 7th term before that, and the 6th term before that. Okay, those numbers, that makes sense. That's easy. It's trickier when you have n's sitting in there. So a sub n, well, what would be the term after it? Well, it'd be an n plus 1 term. And after that would have to be the n plus 2 term, and after that would be the n plus 3 term, and so forth. And how about before a sub n? What would have to come before that? Well, we've kind of written that a few times. That would be your n minus 1 term. And your n minus 2 term would be 2 before that. Or your n minus 3 term would be 3 before that. So when we work with these sequences, you have to kind of just envision where things are located in reference to one another. So if I make some sort of rule, and I'm going to come up here and make something up. So for instance, if I make, and I say n plus 3 is equal to a sub n plus a sub, I don't know, n minus 1. Okay, now this one's kind of a tricky one. I'll start you off slower than this, but I just want you to see on this slide what that means. If I wanted to find this term right here in a sequence, I would have to go back 1, 2, 3 terms to get to the a sub n term. So I'd go back 3 terms and find that value, and add to it, and think about where your n minus 1 term, oh, that's the one right before that. So I would have to go back several terms, add those two together, and that would get me this term way down the line. So just look at this as though these are all lined up and where they would fall in reference to one another. Let's try a couple. All right. Now this one actually isn't too bad. It's an explicit rule, and those are always easier because it's just pretty straightforward. This says find the first 6 terms and the 100th term of the explicitly defined term. All right, so here we go. To find u sub n. Okay, so to find the nth term. Well, I want to find, and I'm going to come way over here because I'm going to fill in a lot of stuff here. I want to find the first term. So that means my n is a 1. So in my numerator, that n on the top is really going to be a 1 plus 1 divided by 1. So the first term ends up equaling 2. Okay, if I want the second term, well then I'd have a 2 that I'd put in for n, so 2 plus 1 over 2, so that would end up being 3/2. If I want the third term, well, I'm just going to take 3 plus 1 over 3, which is 4/3. And if I want the fourth term, then I'm going to put 4 in for n. So 4 plus 1 over 4 would equal 5/4. Okay, now here's the deal. We're in pre-calc. We don't really need to write that out every time. We can figure this out in our head without having to write these steps down necessarily all the time. Now you can if you need to, but here's the gist of it. Look at what's happening. What's happening with your numerators as you go across? What's happening with your denominators? Don't you figure we can guess what the next term would end up being? You know, numerators are going up, so this would have to be a 6, and this would have to be a 5. And that's the 5th term, it looks like. So then I'm supposed to find the first 6 terms. So then I'd have a 7/6 for the 6th term. All right. And then let's just stick in a dot, 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 because we have to then jump way down to the 100th term. Well, if I put 100 in for n, then I would have a 101 over 100. Okay. And so this is the sequence that they're looking for then, those values. Now that was an explicitly defined one. Let's try something that's more recursive. It says find the first 4 terms and the 8th term of each recursively defined sequence. Well, first of all, let's talk about the fact that they want 4 terms and then the 8th term, but it's recursively defined. Well, the only way to get to the 8th term is to know the 7th. And the only way to know the 7th is the 6th, and thus, really, I have to find all 8 terms on this. All right, so let's look at this rule. So they give us the first term, so we go ahead and write. It's 8. Got it. And so then I'm looking for my next term. And I come over here and I look at this rule, and I say, all right, to find the nth term, I'm going to have to take the n minus 1 term. Now think about where that's at. Where is that in reference to what I'm looking for? Well, that's the one right before it. N minus 1 is right before n. So I'm going to take the term before it and subtract 4. So if I want this term, I have to take the term before it and subtract 4. So that'd be 4. If I want this term, I have to take the term before it and subtract 4. And if I want this next term, I have to take the term before it and subtract 4. If I want the next term, okay, and it said the first 4 terms, all right, but we really got to find all 8. So really all you're doing is subtracting 4 each time, right? Got the negative 4, subtract another 4, subtract another 4, subtract another 4. Am I far enough yet? That's number 7, subtract another 4. Okay, so here's your first 4 terms that they want, and here's the 8th term that they want. Okay, let's look at B. Getting even trickier. Look at what they've given us now. Now they're saying the k plus 2 term. To find the k plus 2, you're going to have to take the k term plus the k plus 1 term. So again, and look back at that other slide where we listed those all out. think about where those would all line up. The k plus 2 term is what I'm looking for. So I would have to go back 2 places to get here, only go back 1 place to get here. So if my first term is 2, and my second term is -1, and now I'm looking for this next term here, well, this is the k plus 2, so I'd have to go back to the k term, add the k plus 1 term, and that would get me this. So basically I'm just adding these two numbers together. Okay, so that get me a positive 1. Now I'm looking for this term. Well, I've got to go back 2 spots, so I've got to use this one for the k term, and this is the k plus 1 term. Because, again, think about where these are in reference to each other. This one is what I'm looking for. This is the one 2 back, this is the one that's just 1 back. So I'm always adding the 2 before it. So a -1 and a 1 would get me a 0. Add those two, you're going to get a 1. Add those two, you're going to get another 1. Add the 2 before it, now I'm going to have a 2. Do you see what I'm adding here? I guess I should have been using my little pen here. To find this one, I have to add the 2 before it. To find this one, I have to add the 2 before it. To find this one, I have to add the 2 before it. To find this one, to add the 2 before it. So my next one, add the 2 before it. Add the 2 before it. How far am I? I needed the first 4. 1, 2, 3, 4, 5, 6, 7. Oh, I was done right here at 3. That was the 8th term. All right, so don't overthink those problems. I know that the notation looks crazy scary. Oh, and I guess I didn't even talk about this other part over here. Sorry. These things where they're telling you about these inequalities. All they want to make sure is that when we write sequence notation, the very first term is always an a sub 1. We can never let this sub number be a 0 or a negative. It always starts at 1. So all this is designating is making sure for all of these different sub numbers that your sub number doesn't end up being a negative or end up being 0. So by keeping this greater than or equal to 2, like right here, if I had let it be a 1, then I'd have a sub number of 0. So we don't really use these other than, that's just their proper notation they're putting in there. All right. A few more. Here we go. So let's kind of tie this all together. Now, on your homework, they give you a sequence, and they ask you to find some or all of these things. And I don't feel like they always ask you in the best order. So I've kind of put this in order of how you probably should find things. Now, they may not ask for all of it. They may ask for like the common difference and the explicit rule. Or maybe they don't even ask for this, but you kind of need this to be able to write your rules. So you're always going to start off and find your common difference. Now, in this case, it has a common difference because you can look and see what's going on. It looks like we are subtracting 3 each time. So then the common difference would end up being a -3 since we're subtracting. Our recursive rule would be a sub n equals, and remember the recursive rule always uses the term before it, and we are subtracting 3. The explicit rule always uses the first term. So the first term is -5, and we are subtracting 3 n minus 1 times. And then what we can do is we can find the 10th term by plugging 10 in for n. And so this really just becomes 9, so -5 minus 3. Make sure you're doing your order of operations. So it's a -5 minus 27. I'm running out of room, sorry. So it looks like it would be a -32 is the 10th term. All right, so that's all of the different parts of that sequence that we've talked about. Okay, so this one's yours. You take a minute to pause the video and fill out this page. All right, go ahead and check your answers, fix anything you need to fix, pause the video, and move on when you're ready. All right, so here's the last one. This is a tricky one because, again, it ties a lot in with what we've done, but it makes you think a little bit more. So, and you have about 4 or 5 of these on your homework, so take close notes here. All right, so it says the second and eighth terms of a geometric sequence. Okay, so a couple things. This is a geometric sequence. That's going to be important. So the second and eighth terms are 3 and 192. So I'm going to rewrite that up here. So basically we're saying a sub 2 is 3 and a sub 8 is 192. All right, so they want us to find the first term, the common ratio, and an explicit rule. Okay, so think about what I know here. I've got, all right, so there's something for my first term. I'm looking for that. My second term is a 3, and then here's my third, fourth, fifth, sixth, seventh, eighth, and way down here I know that that's a 192. Now this one's not too hard because the terms are close together, but let's kind of go through this algebraically because, again, you're not going to be allowed to just write your answer and do it all in your head or sit there and just press enter, enter, enter in your calculator. You have to have algebraic work to justify this. So let's talk about what's going on algebraically here. So if I were to look at an explicit rule, it would look like this. A sub n equals the first term. Oops, don't know the first term. But since it's geometric, I know I'm going to be multiplying by some common ratio, which I do not know yet, to the n minus 1 term. Okay, so let's take that the next step. Let's say that since I know the 8th term, that would be equal to the first term times r to the 7th power then, right? But the problem is I don't know the first term, and I don't know r. I do know a sub 8, but there's too many unknowns here. So let's think about what would happen is, what if it was the 8th term that you were looking for, but you don't know the first term, so instead you're going to use the second term. Well, then you'd have to multiply by r, but you wouldn't have to do it as many times because you started at the second term instead of the first term. So could you think about how many times you'd have to multiply by r? We'll come up here. To get from the second to the 8th, you're going to multiply by r once, twice, 3, 4, 5, 6 times there. So this is really an r to the 6th. Okay, now before I continue on, let's take this deeper because you're going to have a little crazier numbers on your homework. What if I knew the, let's just make something up here. I'm going to come up here. What if you knew the 18th term, but you didn't know the first term, you knew the 12th term? How many times do you suppose you'd have to multiply by r? Well, to get from the 12th to the 18th, if you just think about it, well, you're just subtracting those two values to get there. So I'd have to multiply it 6 times to get that 12 up to the 18th. So then it'd be r to the 6th. So what's going on here is this number here and this number here need to add up to 18. That you're going to start at the 12th, go 6 more times, you end up at the 18th. So right here you can see I'm at the first, multiply by r 7 times, you end up at the 8th. Second, go 6 times, you end up at the 8th. Now, I don't have to do anything else with this. I'm going to actually use, this one's not helpful to me because I don't know the first term. This one is, because I know these things. The 8th term is 192. The second term is 3. Now I don't know r, but it's to the 6th power, and I bet I could find that. So let's divide by 3. So 192 divided by 3 is what? That's 64 equals r to the 6th power, and take the 6th root of both sides, 6th root, and the 6th root of 64 is 2. Or is it? What are we supposed to be doing when we square root both sides? Yeah, this actually should be a plus or minus here. And anytime we do that, now it does, I shouldn't say anytime you root both sides, but anytime you take an even root of both sides, so if you square root, fourth root, sixth root, you should be attaching a plus or minus on that. If it's a fifth root, you don't do that. All right, so what this means to us then is maybe we don't have quite enough information on this sequence to know for sure. I kind of have a couple options. I could let my common ratio be 2, or I could let it be -2. And so I work through this problem twice, figuring out the two options. So if I'm going to multiply by 2, multiply by 2, multiply by 2, multiply by 2, okay, how do you suppose I back up? So to get back to the first term, which was one of the things they wanted, all I have to do is divide by 2. So my a sub 1 would end up being a 3/2, unless my common ratio was -2, in which case it'd be a -3/2. So I'm going to put a plus or minus on that 3/2. All right, so now we've got the common ratio, we've got our first term. Let's write our explicit rule. So this was part of the answer, this was part of the answer. Notice we didn't find those in the same order that they listed it there. So be aware, you just have to find the stuff. It's not always in the order they ask for. Okay, so your rule then. The nth term. This is an explicit rule, so you got to use the first term. Well, I'm going to let the first term be 3/2. And then I know that it's geometric, so I know I'm going to be multiplying by 2 to the n minus 1. And that's my explicit rule. Now I can't put plus or minuses on my 3/2 and my 2 because it's not like the plus or minus 3/2 could go with a plus or minus 2. It's one or the other. And so the positives go together and the negatives go together. So we kind of have to write that separately to make sure that if it's a -3/2, then it's going to be a -2. Make sure that negative gets put in parentheses so it goes to that power as well. All right, so that's the first part of 9.4. We spent 3 days on this lesson, so that's the first part, but you really have to have this down pat to be able to move on to the next part. So make sure you get through all of these problems here. Good luck.